You've spent a lot of time working with linear functions. Each of these is a linear function. What we're doing in this unit is called systems of linear equations or linear functions. A system of equations is when you think of two equations together. Okay, so this introductory activity, if you've gone through and done it, you should understand what that, kind of have an insight into what we're going to do here. Each of these, each of these equations here is a linear function. So what you're asked to do here is take both of those linear functions and create a table for them. If you created a table for this y equals 4x, you might have done something like just pick numbers like this. I don't know what you did, but I probably asked you to stick in positive numbers. I don't know. Let's stick to positives here. I think it's probably easier if you just think y is 4 times as much as x, rather than trying to sub the number in each time. Just think if this is 0, this is 0. If this is 1, y is 4 times as much. If this is 2, this is 8, and so on, right? Just 4 times as much. And not necessarily how far you have to go here, but 6, 24. You probably filled up the table. 7, 28. These are just whole numbers. You could put any numbers. How many different pairs of numbers could you put in each of these tables? Are these the only pairs you could put in this table, or are there others? How many pairs exist that would work here that you could put in this table? Are these the only 9 pairs that you could do? No, there's more, right? If I wanted to, I could put 0.5 and do 4 times 0.5 and get a 2, but we don't necessarily need that right now. There's an infinite number of pairs of numbers that work there, right? The infinite number of pairs of numbers we could have put in this table. There's an infinite number of things which you know because when you draw the line for that, right? So we're going to draw we're going to draw the line for y equals 4x. Y equals 4x, 0 y-intercept. If you're trying to draw the line for y equals 4x, you can put all the dots and then just connect the dots if you want, right? You could put all these dots and then connect them since we made the table anyways. Or if you know that the slope is 4, you can draw it, right? Y-intercept of 0, slope of 4. So there's that line, right? That's y equals 4x. The other one up here, let's do it in a different color. Let's do this one in green. If I was to do the same y values here, 0, 1, 2, 3, 4, 5, 6, 7, 8. This one says two numbers add to 10. So if the first number is 0, what's the other number? 10. If the first number is 1, this one is 9, 8, 7, 6, 5, 4, 3, 2. This one, as one number goes up, the other number goes up. This one, that's why the line goes up. This one, as one number goes up, the other number goes down, right? One's dropping as one's increasing here. If you're trying to graph this one, there's lots of different ways. If you have the table in front of you, you can just put the table down there. If you're trying to graph it without the table, the simplest way to graph x plus y is 10 is to just do the x and the y-intercept, right? If I want the y-intercept, I put 0 in for x. What does that give me if I put 0 in for x? It gives you that, right? Y is 10. If I want the x-intercept, what do? Put in 0 for y, and you get x is 10. If you have an equation that says x plus y is a number, the x and the y-intercept are that number, right? X plus y is 100, the x and the y-intercept are going to be 100. This is going to be this line that slopes down from the number on each axis here. If I draw this line here, okay, what do you notice about the graph? So this is each equation here. This was x plus y equals 10. And the other one's y equals 4x. What do you notice about the graph? What's an important point on there? What's significant about this point right here? First of all, what are the coordinates of that point? 2, 8, right? 2, 8. 2, 8. That's called the intersection point. What does the word intersection mean? If you're taking your driver's test, how do they use the word intersection to refer to things? You talk about driving and roads and stuff. Two roads cross, right? That's an intersection, right? Two roads cross if you talk about an intersection. the two lines, the red and the green and the blue line, intersect at that point. Okay, intersection point is 2, 8. If you look back at the table, the intersection point is the point that's on both of the lines. It's also right here, right? It's the only point that's in both tables. It says here, are there any values that satisfy both equations? As in, do they work in both of them? 2, 8 is the one that works in both. Okay? 2, 8 is the only point in both. Okay, it's the only pair of numbers that works in both. If I asked you at the beginning here, if I said one number is 4 times the other, one number is 4 times the other, and the numbers add up to 10. If I just asked you one of those things, if I said one number is 4 times the other, what are the numbers? You'd probably start to give me all kinds of things. If I say one number is 4 times the other, what are the numbers? Can you give me a definite answer to that? No. It could be any one of the pairs that you have here, right? Or if I said two numbers add up to 10, what are the numbers? You could give me a lot of different answers, right? Two numbers add up to 10, it could be 5 and 5, 4 and 6, all those things. If I give you both of those conditions together, if we say both of those things together, if we say one number is 4 times the other and the two numbers add up to 10, then are there a lot of different things the numbers could be? If both of those conditions exist, what do the numbers have to be? They have to be 2 and 8, right? Because they add up to 10 and one number is 4 times the other. They have to be 2 and 8. There's only one pair of numbers that works in both of these things. That's the solution to the system of equations. Okay? If you talk about a system of equations, you're talking about 2 or more equations. When you look at those together, it's called a system of equations, and the solution is the pair of numbers that works in both, or the set of numbers. Okay, so later on here we're going to have a definition of, somewhere we're going to write a definition of what a system of equations is, probably in this space down here. But this is a good, simple example to use for this. Okay? Where can we write it here? 2, 8. Works in both. It's the solution to the system y equals 4x and x plus y equals 10. This is a system of equations. The solution is 2, 8. 2, 8 is the solution to this system right here. It's the intersection point. Intersection point is that. The intersection point is the solution. Okay, point of intersection gives the solution. So this kind of gives you an idea of several different ways you could find the solution to a system. If I give you the equations, I'll go back down there in a second. If I give you two equations and ask you what's the solution to that system, you could do it by creating a table and seeing which one occurs twice, occurs in both. Or it might be faster to create a graph of each one and then look for the intersection point. This is what the first section is about. The first section is about solving a system of equations, taking a system of equations and finding the solution by graphing. Graphing the two lines on the same grid, finding the crossing point. It's going to be pretty inefficient to try and solve systems by creating a table, because here we got lucky, we found the solution pretty easily, but it may be that you're going in the wrong direction, you never find the solution. This whole chapter, both chapters 8 and 9, this whole unit is about solving systems and using them to solve problems. You're going to find different ways to solve them.